Welcome. Welcome to second session on programming. It is called as programming paradigms. It is called as programming paradigms. Paradigm is model, style, way, pattern. Meaning is it can be a model, it can be called as style, it can be called as way or pattern. The context of programming paradigm refers to the way of writing a program. How do you write a program? How do you write a program? So we have different programming paradigms. So, but using one of the programming paradigms, you may write the program. And depending on your requirement, you may choose one of these paradigms, and in turn, will be choosing one of the languages. But the point to be noted is a language may support one or more paradigms. In majority of the cases, it supports one or more paradigms. But most of the programs may be written using one programming paradigm. The other programming paradigms may also be supported by that language. So if a language supports a particular programming paradigm, then you can write programs easily using that programming paradigm. Why programming paradigms? Why we have different programming paradigms? The advancements in hardware, that is one reason. The advancements in hardware, change in the purpose for which programming is done, and increase in complexity of the programs is making different programming paradigms to evolve and apply to different problems. The advancements in hardware is keeping on changing. So it is continuously changing. Hardware is continuously changing. Now, why programming paradigm changes when there is a change in hardware? It is because so you have to exploit the hardware. What are the features that are present in the hardware? You should be able to exploit them. Suppose in the good olden days, so there was only one processor, and that processor execute only one program. Now you have what is called as multi-core systems, multiprocessor systems. How do you make use of that hardware? How do you make use of that hardware in an efficient manner? Next, change in the purpose for which programming is done. So initially started with just numerical programming, but now you can do huge number of tasks. You can manipulate numbers, you can manipulate strings, you can manipulate images, you can manipulate videos, etc. So it is keeping on changing. So maybe you need to change, or you need to do modifications to the existing programming paradigms. An increase in complexity of the programs. Also making us to choose different programming paradigms. So no language supports a single programming paradigm 100%. So a language supports usually one or more programming paradigms. One or more. One, not 100%, but majority, maybe 80%, 90%. It is based on the programs are based on that programming paradigm of that language. So the other programming paradigms may also be supported. List of programming paradigms. So the list of programming paradigms. So these are the list of programming paradigms. But mainly, if you refer to many books, so these are the programming paradigms that are considered: procedure-oriented, object-oriented, function-oriented, logic-oriented, event-driven. So the other programming paradigms, usually we don't give much importance, but it started with machine code, and also we are at present in this concurrent programming, and also client-server programming, concurrent programming and client-server programming. But these are the major things that are considered when we discuss programming paradigm. So I started with machine code. Excuse me. started with machine code. So in the case of the machine code, programs are written using machine language. That is, in terms of ones and zeros, programs are written using machine language. So in terms of ones and zeros, it is difficult to write such programs, and moreover, every machine has its own instruction set. So the machine code for each computer may vary. So the programs are not portable, the programs are not readable, the programs are prone to errors. But nevertheless, because you are writing in terms of ones and zeros, they are efficient. Consider next programming paradigm, assembly programming, which you can say an enhancement of machine code programming, machine language programming paradigm. So assembly language means instead of using just ones and zeros, we use what are called as symbolic codes. Symbolic codes. That means symbols are used. Symbols can be single characters or group of characters. Like say A. And you may use B. And for carrying out the operations also, you may use something like add. Okay. And you may use sub. So like this, different symbols may be used. So here you can say there are single characters. Here you can say there are multiple characters. But programs are written using this symbolic code. Say add AB. It means add the contents of A to B, and probably store the content in B, or it may be A. Again, it depends on the machine. So for efficient programming, for particularly writing these device drivers, you go with the assembly language programming. Some programming languages have indirect support, like C. So in C, you can write assembly code also. You can write embed assembly code also. But anyhow, how do you embed? It's beyond our scope. But you can write assembly code as part of the C code. Next, when the programming languages were introduced, when so-called high-level programming languages are introduced, it started with what is called as unstructured programming. That means they don't have any structure. They don't have any structure. So in the sense that the flow of execution may not be sequential. Generally the flow of execution is sequential. Say first instruction and then second instruction, like this. So you can go on, maybe say 10th instruction. So usually what happens is you will be executing first instruction and then second instruction and then dash 10th instruction. But with unstructured programming, you are permitted to jump from one instruction to another instruction. Say at this point of time, I may have some instructions similar to say the jump second. Here there may be third one also. The third, fourth, etc. are there. But what you are doing at this point of time, you are jumping to the second again. So you can jump as you like. That leads to what is called as unstructured programming. Always use structured programming, but if you use unstructured programming concepts, then it may result in unstructured programming. So assembly language supports this unstructured programming using statements called as jump statements. Even these high-level programming languages like C also support this unstructured programming in the form of go to some statement, similar to jump, go to some statement. So unstructured programming leads to programs which are less readable. Because you can jump from one location to other location as you like. So finally, it may be confusing for you. And also others who read or try to understand your programs. Next is structured programming. So high-level programming also started. High-level programming language also started by unstructured programming, but later what are called as structured programming concepts were introduced. Structured programming concepts. Structured programming concepts are introduced. Structured programming concepts are introduced, and the structured programming concepts are sequencing, selection, and repetition. These structured programming concepts are supported by all the languages. Sequencing means executing the instructions one after the other. Selection means you execute this certain statement based on some condition. Okay, if this condition is true, execute this. If it is not true, execute something like that. Selection. And then repetition, you will be executing certain statements repeatedly until that condition becomes false or some fixed number of times, say 10 times. 10 times. So all the programming all the programming languages support this structured programming. So you have to use appropriate concepts of that language. As I told you, selection means based on some condition. Repetition means you will be repeating certain statements based on some condition or some fixed number of times. Next one is procedure-oriented programming. So your programs are modeled after procedures. That means your program will be divided into what are called as modules or procedures. So you will be calling different procedures depending on your requirement. So entire program can be considered as a collection of procedures. Each procedure performing a specific task. Object-oriented programming. C is a procedure-oriented programming. Please remember that. C is a procedure-oriented programming. So early programming languages like Fortran, Pascal also are procedure-oriented programming languages. Next came object-oriented programming languages. They came into picture because the complexity of the problems increased. To handle the complexity, go with object orientation. The main advantage of or main principle of this object-oriented programming is it brings together the data and the operations. That operate and the data are brought together. Data and the operations that operate and the data are brought together. And programs are modeled after real world objects. Everything is in terms of object. What is the object? What is the data associated with the object? What are the operations that can be performed on those data belonging to that object? So until recently, the object-oriented orientation or object-oriented programming paradigm is considered the best one, but some loopholes are found at present, and there is one article called as Collapse of Object-Oriented Programming. You can read it out if you want. So C++, Java, Python, etc. are object-oriented programming languages. Functional programming is based on what is called as mathematical functions. Your programming similar to the use of mathematical functions. Never use mathematical functions. So how do you write, say, f of x. So we'll be writing like this. Or sometimes if f of x does something and based on that output of that f of x, if you want to perform another function, you can write g of f of x. So your programs will be like this, something similar to the mathematical functions. And the advantage is they don't have any side effects. and they don't use these variables, etc. They don't use variables or loops. So everything is done using mathematical functions. AI languages are usually function-oriented programming languages. AI languages are usually function-oriented programming languages. Example is Lisp. Example is Lisp. Logic programming languages. Logic programming languages. Logic programming is based on facts and rules. So logic programming languages are based on what are called as facts and rules. Are based on what are called as facts and rules. Facts and rules. So we'll be having certain facts, and we'll be combining these facts and rules to derive new facts. To derive new facts, combining them. So facts and rules will be there, and there will be rules which allows you to combine the facts and also the rules, and new facts will be derived and new rules will be derived. Again, AI field is using this logic programming language. Example is Prolog, and is basically based on what is called as mathematical logic. Mathematical logic. Event-driven programming language. Event-driven programming language. So they are based on what are called as events. So events can be, say, clicking a button, typing a text, or timer reaching a value. Probably you might have seen all these things. Whenever you trying to fill the application, you will be entering the text, click some buttons like save, submit, etc. So that is nothing but event-driven programming language. Associated with each event will be an event handler. Event handler. That event handler handles that event. So that means your code is divided into what are called as event handlers. Your code is divided into what are called as event handlers. Event handlers. So some of the languages are Visual Basic, Visual C++, Java. Non-procedural languages, non-procedural programming paradigm, where you specify only what you want to done, not how you want to done. In the previous ones, usually specify what you want to do and how you want to do. Here you specify only what you want to do, what is required. The code is small in size, but is difficult to write and understand. Though code appears to be small, so it is difficult to write. And SQL, called as structured query language. Structured query language. One such example. Concurrent programming. Concurrent programming which exploits the presence of multiple processors, multi-core systems, or multi-threading. So these are the different concepts. And whenever you have more than one processor, more than one CPU, or multiple cores are also there, you can say core is equivalent to an arithmetic logic unit. So multiple arithmetic logic units there. Then multi-threading, that means something you want to execute in parallel. So all these try to exploit the hardware capability. Java, Scala, Concurrent Pascal, Elixir, Haskell, examples of concurrent programming languages. Similarly, client-server programming, where client requests server response. So you can write client-side programming and also server-side programming. Java, C#, JavaScript, HTML, PHP, etc. are client-server programming languages. So many programming languages cannot be strictly classified into one paradigm, but rather include features from several paradigms. Thank you. Thank you. there is any problem in the recording, please bear. There will be some issues. I have cough. Maybe there may be some issue. Possible, I will try to re-record. Otherwise,